A car is stopped at a red light. When the light turns green, the car speeds up with a constant acceleration. After 2 seconds, the car is traveling at 8 meters per second. How fast is the car traveling after 5 seconds? Let's read that again and write down the important information. So a car is stopped at a red light. If it's stopped, then its velocity is 0. So let's write down that the initial velocity is 0 meters per second. Then the car speeds up with a constant acceleration. We're not given the value of the acceleration, but we know the velocity is going to change. After 2 seconds, the car is traveling at 8 meters per second. So let's write down that at 2 seconds, we'd say the period of time from the initial velocity would be 2 seconds, and the velocity is 8 meters per second. The question is asking, how fast is the car traveling after 5 seconds? So we're given a new period of time, 5 seconds, and we're trying to find the final velocity at 5 seconds. Now let's draw a picture to represent what's going on. The problem didn't give us any positions or displacements, and we're not trying to find them, so we don't have to draw any lines to represent position. We could draw a rectangle for the car at the initial time when it's stopped. Delta t would be 0 seconds because it's the initial time point, and the initial velocity is 0 meters per second. Then we could draw another car with a velocity vector when delta t is 2 seconds and the velocity is 8 meters per second. Then at 5 seconds, the car is moving faster, and we want to find its final velocity. So what equations can we use to solve this? We're trying to find the velocity after a period of time, so we can use this equation to help us. But we're not given the acceleration of the car, so we need to find that first using this equation for acceleration. Notice that these are really just the same equation, but delta v is replaced with v final and v initial, and things have been moved around. Okay, so now let's work through this. First, we want to find the acceleration of the car, which we can do with the information that we have at 2 seconds. The acceleration would be the change in velocity over the period of time. The change in velocity is the final velocity minus the initial velocity. We're going to plug in 8 meters per second for the final velocity and 0 meters per second for the initial velocity, because we're focused on the period of time between 0 and 2 seconds. And we plug in 2 seconds for delta t. That gives us 4 meters per second squared for the acceleration of the car. The problem says the acceleration is constant, so we can use this acceleration to find the velocity at 5 seconds. Using this other equation, now we can plug in 0 meters per second for the initial velocity, 4 meters per second squared for the acceleration, and 5 seconds for the period of time. So the final velocity of the car is 20 meters per second. Instead of using the values for the period of time between 0 and 5 seconds, we could have also used the values between 2 seconds and 5 seconds, and plugged in 8 meters per second for the initial velocity and 3 seconds for the period of time. That would give us the same answer. So, does this answer make sense? The velocity they gave us is positive, and the acceleration is in the same direction as the velocity. The car speeds up, so it's not changing direction and ending up with a negative velocity, so the answer should be positive. The value seems reasonable. It should be greater than 8 meters per second, since the car is speeding up. The unit we got is the unit for velocity, and the problem didn't ask for velocity in a different unit, so this looks good.